All right, hey everyone, Riley here from becominganelectrician.com. In this video, we are going to be focusing on series circuits. We'll talk a little bit about parallel circuits as well, but a couple things that you have to know about a series circuit is that current is always the same, okay? So and again, you guys should also check out my other video I did regarding Ohm's law. So we have voltage, we have current and resistance. And if you're wanting to find any of these values, you just remove one. And then now it would be voltage divided by current gives you resistance. If you want to find voltage, then you would go current times resistance gives you voltage, okay? Again, check the link in the description. Now, a couple other things regarding a series circuit is resistance total is equal to the value of all the resistors, okay? So for example, you can take the resistance of resistor 1 plus resistor 2 plus resistor 3, and that's going to give you your total resistance. Same with voltage, okay? So voltage total is also equal to V1 voltage drop 2 plus voltage drop 3, and also the same with the power, okay? So the biggest takeaway here is current is always the same in your circuit, okay? Now, before we get into drawing our series example, I do want to say that typically, as real electricians out there in the field, when we are wiring things, typically everything is in parallel. The reason for that is because in parallel, the voltage is always the same. So for example, if you look at all the plugs in your home and all your different light outlet boxes, everything is 120 volts, which means that when we are splicing our black to our black and our white to our white, that is in parallel, which means our voltage can stay the same. But when you're first getting started up your teacher and in your schooling, you're going to learn about series circuits, typically DC electronic circuits like, 5 volts, and learning about batteries and polarity and positive and negative. We're just going to keep things really simple. Again, the biggest thing that you need to know is current is always the same, and that's going to allow you to test your answers. All right. So let's just do a quick, this one's a super simple example. We're just going to do just one resistor. Okay. And so right here, this is our AC power source, let's just say, okay? We'll always try to do this as if we are real electricians and what we really need to know. But sometimes you just got to pass the schooling because they're asking for certain questions, right? So we're going to say our source is 120 volts, and then R1, okay, that's what you're going to see. So resistor 1, they're going to give you a value. Let's just say it is 10 ohms. Okay, so we have 10 ohms, and then we know our source is 120 volts. So when we have a series circuit, there is only one path for electricity to flow, okay? And so in other words, if we just follow our wire, that means that we are going to have 120 volts right here. And all we have to do is go 120 divided by 10. That gives us 12 amps, okay? And so I told you in a series circuit, as soon as you can figure out your amperage, then you figure it out for the whole series circuit because current is always the same. Okay, so now we know that going this way is 12 amps and going this way is 12 amps, which means that we have 12 amps right here. And then what's the value of this? Well, it's going to be the same because it's only one resistor or one load in this circuit. But if we start to have more resistors, then it's going to change, right? It's not going to be so straightforward. But as you can see, when I was figuring out this value right here, I found the amperage, and then I would divide that, which again would give you the 10 ohms. So looking here, you might be like, well, that's the same value. Yes. So let's go into another one here. Now, again, this is 100% purely resistive load. So in other words, what that means is this has no inductance and no capacitance. So these are things like baseboard heaters or on your cooktop, like on an oven when you have your resistive element, kind of looks like a coil, the old school kind of ones. These are purely resistive. And so what that means is we can apply Ohm's law directly. And also with Ohm's law here, we also have our power triangles, okay? So this would be P, I, and then V. And again, the same stuff applies. Like if you're wanting to find voltage, then you're going to go power divided by current is going to give you your voltage. Now, there are other formulas based off of these two triangles, which allow you to kind of skip a step. I've never liked using those. I just like to keep things really simple. And I would rather do the 2 steps because for one, it shows your work. Your teacher will always give you marks off of your work, right? And then they'll also give you a mark for the answer. So showing your work is actually more important than almost the answer when you are writing a test, but obviously you want to get the right answer as well. Okay, so let's just say we have R1 for resistor 1, resistor 2, resistor 3. Now, one thing just to say that if this was not a purely resistive load and we were talking about inductance and capacitance, you are going to be getting into what's called the Pythagoras Theorem, which is where we are trying to find the hypotenuse and our power factor, okay? Because this is like your second and third and fourth year. So essentially this is like what like you're paying, and like this is like what you are actually getting out of it. So for example, nothing is 100% efficient in this world. And so when it comes to our motors and different electrical loads, we're always looking for like, what is this power factor? And essentially this is like what we're paying. This is like what we're getting out of it. And you will learn that later on in your schooling, okay? And we can also cover that in upcoming videos. But in a purely resistive load, we don't have that. It's just a matter of basic voltage, current, and resistance. So at every single one of our loads, you always want to be drawing a triangle, and I always suggest drawing the triangles just a little bit, or like, your T's. Draw your T's just a little bit bigger than what you think you're gonna need, and it's always gonna allow you to be a little bit more organized in your math, okay? So let's just talk about as if we are real electricians. We're going to go 120 volts, okay? And now, for me as the teacher, I am going to be giving you just random examples here, okay? So let's just say we have 10 ohms, okay? Let's say we have 20 ohms, and then let's say we have like 14 ohms, okay? So if we look up here, I told you that to get the total resistance, we can simply just add up our resistors. And as soon as you find out your current, we know that current will always be the same. So for example, if 4 amps was here, we knew that 4 amps was going through, so it would be 4 amps, okay? But what we're going to do is we are going to add up our resistive values. So 10 plus 20 plus 14, so that is 30, 44. Okay, we don't need a calculator for that one. And then now 120 divided by 44, I'll bring out a calculator, okay? So let's just go 120 divided by 44 is going to give us 2.727 amps, okay? And usually you want to go to 3 decimal places. It's a little annoying, but this is going to typically always going to give you your answer, because when it comes to a test, even if you are off a little bit, sometimes things are strict when it comes to a test and they want to know exactly what it is. So in this case, even though it is 2.727, if this was 5 or higher, then it would be 2.728, if that makes sense, okay? So always to 3 decimal places. And so what that's going to do is now we're going to have 2.727 amps, 2.727 amps, okay? Because remember, as soon as you find out current, it's always the same, right? So right here, as soon as we know that it doesn't matter if we find out current here or find out current here or here, there is only one path for our current to go in this circuit, right? If we follow along, it has to go through resistor 1, it has to go through resistor 2, it has to go through resistor 3. So in a series circuit, which is only one path for our current to flow, our current always stays the same. So as soon as you figure out your current, no matter what the teacher is asking you here, as soon as you find out current, it's going to give you a lot of your answers. And so that's a really powerful one to get in a series circuit, okay? And then let's just put it in here. So 2.727 amps. And now to find out our math here, it's just a matter of going amps times ohms. Okay, just like in our Ohm's law up here. So if we want to find voltage, which is what we want to find voltage, then we are just going to go current times resistance, and it gives us what's called our voltage drop at each one, okay, at each load. So 2.727 times 10. I could have just done that one, but we're just going to go 27.27 volts, okay? We will do the next one, so 2.727 times 20, and this is 54.54, and that's volts, okay? And then we will do the last one, so 2.727 times 14, and that is giving us 38.178 volts, okay? Yes, it's a little bit annoying to do like all the decimals, but I'm telling you that when it comes to your tests, it's worth it. You're always going to get your answer. And so now if you want to find out power, like let's say the teacher comes and they say to you, we want to know the power of resistor 1. Okay, so in other words, they might ask, what is the value of P1? And essentially load 1. This could be like a light bulb, it could be a baseboard heater, whatever it is. What they're saying is this is a purely resistive load, and we're wanting to know what is the first load's power. How much power is it consuming in the circuit? And we would just multiply volts times amps gives us power. Okay, we're going to be using this triangle right here. And so to get power, we're just going to go amps times volts gives us our power. And we will just do the 1 here, okay? So we have 27.27, and we're going to go times 2.727. All right, so I'll just put a line right here, and we're going to go 74.36 and 5. So if we're going to 3 decimal places, so 9 would put this to 3, but it would not put this to 6, okay, because it's 3. All right, so 5, and this is watts, okay, because it's power. So power is watts. And if you wanted to, then you could just do it right here, put your value right there, same thing. And again, this is why you want to kind of think about the spacing of your T's. You make them a little bit bigger than what you need, and it allows you to see all your values. And when you show your work, the teacher can look here and they can see everything. Okay, so now another thing I want to quickly talk about is just parallel in this video. And we're not going to talk about equations or anything, but again, these principles that you can see up here, this is all based off of a series circuit. Current is the same. You can add up your resistors like normal. You can add up your voltages just like this, and that is a series circuit. And if you follow these, it's going to allow you to go very, very far with your schooling really easy. And the biggest trick here is just knowing how to test your work. If you know how to test to see if you got the right answer, then you're on your way. So let's just look at a parallel circuit. So let's just say we come here, and then what happens is you're going to see a parallel circuit like this, okay? And we just do like a little dot like that just to kind of show that it's been spliced. And typically this would be like your black wire. You'd be like in an octagon and it's spliced on. Your white would be in here too, but this is like how like we draw it. But then we splice on, and then we're going here and you put like a staple, you know, you'd have like your staple, and then you're splicing on again into another octagon box. And then now this is like imagine just like your lights, right? So let's just remove some of this stuff. So we're just going to do it just like this because this is typically how you would see it. And so let's just say we have 120 volts because again, I like to try to keep things very consistent with real electrical. When you're out there, you can apply this knowledge. And so if we draw our T's, right, so we're going to have 120 volts. We draw our T's, we're going to have 120 volts. And so in a parallel circuit, this is a parallel circuit, all of our voltages will stay the same if we only have one load in that splice. But for example, if we add another resistor in here, our voltage would not stay the same because right here, this is in series with each other. Because remember, there's only one path for current to flow in this splice. And if we have 2 electrical loads in line with each other, this is where we can start, let's say it could be like 60 volts and then 60 volts. Now in the real world, again, when we are wiring our lights and our plugs, everything's in parallel. And we want that because we want our voltage to be the same. If you are looking at all your different electronics in the home, whether it's a TV, a blender, a toaster, whatever, you're going to look at the nameplate, at the sticker, and it's going to say how much voltage it requires, right? It's not going to ever say we want 60 volts or we want 75 volts. It's always going to say we want 120 volts, or if it's going to be like a heavier duty item, such as let's say your stove, it's going to say it wants 208 volts or 240 volts. And so you have to supply it with that voltage. And so when we have our source, which is 120 volts from the panel, which is just one circuit and a neutral, then each plug or each light is getting 120 volts. That way, every light, every device is getting the required voltage, which means that it's going to get its proper brightness. In a series circuit, again, even if it's AC, so let's say we have 120 volts. In a series circuit, again, this is only one path for your current to flow. Okay, only one path for your current to flow. It goes like that. And so again, as soon as you find your amperage right here, right? As soon as you find your amperage, you can find your amperage here. You can find your amperage here. You can find your amperage right here. In a parallel circuit, couple things I would just want to quickly say is if we are drawing our T's here, okay? So in our T's, resistance, so let's say this is like 10 ohms, and then let's say this is like 5 ohms. Your total resistance in a parallel circuit at your source always has to be less than any of the electrical loads. That's one thing to know. See, in a series circuit, we can simply just add up our resistors. So for example, if this was 10, let's just go ohms, and this is like 5 ohms, and this is like 20 ohms. We know that we have 35 right here. All we have to do is do the math. We get our amperage right here, which gives us our amps, and our amps. And then all we have to do, now we can find voltage, voltage, voltage. That's how easy a series circuit is. As soon as you find your current, it goes a long way. In a parallel circuit, your voltage stays the same. So that's one thing that you can typically always rely on. Typically in a parallel circuit is your voltage is always going to be the same. Unless you're doing funky stuff and now you have 2 resistors in line, then you can't. That's where what's called a combination circuit, which will be another upcoming video. We'll do a combination circuit. But right now you can see if we have 10 ohms and 5 ohms, the total resistance of the circuit is going to be less than any of the loads. So for example, it could be like 4 ohms or it could be 3 ohms. So for example, if this was 1 ohm, then this would have to be like 0.9 ohms or 0.8 ohms, all right? That's just really important to know. So that's it for a series circuit. Current is always the same. We can add up our resistors, we can add up our voltages, we can add up our wattages. And then again, if you would want to find your wattage, then it's just volts times amps, and you just follow your 2 triangles. And closing out here, there's 2 things I want to say. So number 1 is always look for what the teacher is asking for on the test. So if the teacher has given you a series circuit, let's say just like this, okay, giving you a series circuit, and all they're asking for is, let's say they're asking for what is the total resistance of the circuit. So in other words, they just want to know this value. They don't care anything about this, or this. Like they don't care about any of these. They just want to know what is the total resistance of the circuit. And so you just really got to look at that, because it's going to save you so much time on the test, because sometimes they'll give you a question. They say, what is the total resistance of the circuit? And then upcoming questions may have nothing to do with anything else from this point on. And if the question is based off of, all of these, then again, make sure to show all your work, because you will also be able to test your work to see if you got the answer right, because everything kind of works with each other in a series circuit. One last thing I'll just quickly say about series, just because you might be like, well, where do we use series in the real world? So let's just say we have a 12-volt source, but then let's just say we have a resistor and it needs to be 5 volts. Okay, so what we can do is we can actually put another resistor in line, and if it has a 7-volt voltage drop, so whatever the ohmic value is here, so in other words, we are giving our resistor or our load 5 volts by putting an inline resistor. So that is like one use that you could be using series, but this is more to do with like electronics, or sometimes motors and stuff can take advantage of series to get more power and all that stuff. But we're not going to cover that in this video. But again, so a series circuit, these are the principles to follow. The biggest one really is just current stays the same. As soon as you find current, then it's the same in here, here, and here. And then you can easily find out all your values really, really quick. Again, just make sure that you are reading what are they asking for on the test, because you can waste a lot of time trying to figure out all these answers when meanwhile, they just wanted to know if this is R1, they're going to say, what is the value of V1 right here? They just want to know that. All right. But sometimes you do have to answer everything or whatever to get that value. So Read it closely. It's going to allow you to be faster on your test. And then again, if you don't know about Ohm's law and stuff, check out my other video where I talk about Ohm's law. I believe I also talk about the power triangles in there as well. I also have another video about what is a power source and then what is a load, because sometimes that kind of stuff is a little bit tricky when you just see all these like different icons and stuff, and you're looking and you're like, well, how does this apply in the real world? That was probably the hardest thing for me as an electrician, was how does this actually relate to the real world? And again, so since this is a purely resistive circuit, these are things like baseboard heaters, old school incandescent light bulbs, right? So we don't really have tons of resistive elements, like purely 100% resistive. Typically, everything has some inductance and some capacitance in it. And again, that's where you're going to be getting into your Pythagoras Theorem, where we are looking at the power factor and the hypotenuse. And again, this is like what you're paying for. This is like what you're getting essentially. And if we can bring this down with, in other words, make it more efficient, then what we're paying is closer to what we're actually getting out of that piece of equipment. Now, one last thing just to wrap up here. So typically we don't talk about wires having resistance, but they actually do. And if you can figure out the resistance of the wire in one line, that means that, because you actually have two wires, right? You have your black and you have your white. So let's just say this was like 0.15 ohms, then you would actually have 0.3 total ohms of resistance just off of your wires. And that's to do with what's called voltage drop. And sometimes you have to upsize your wire. So for example, if you had a number 14, if it would give too much voltage drop, then you might have to upsize to like a number 12, or number 8 or number 10 or whatever. You're going to have to upsize the wire to get less resistance, even though the load can easily handle it. Sometimes if it's a long length run, and that's sometimes to do with the utility company and yourself. Like you will hear about the 3% total voltage drop, and then I think the total is like 5%, but that's to do with like the utility company. So not to get into that, but typically you will learn about the 3% voltage drop. We're not allowed to have any more than that. Therefore, we might have to upsize the wire. But in basic circuits, we are just looking at the loads, but the wire also has some resistive value in there, which in a typical home, it doesn't really matter, but this does matter a lot if you have to run something to a special piece of equipment, such as, let's say, in a hospital, x-ray equipment or stuff like that. That stuff gets very serious because it's like everything needs to be, at the highest quality. Or even like the power coming into the home, because let's say from the transformer outside, let's say you're getting 120 volts, but let's say it's a long run to the home. And then by the time you get to the home, let's say it's 112 volts or something, you're always going to want to try to get as close to 120 volts as possible, because that is what equipment is rated for, right? There is always a little bit of variance. And that, again, that's like where like that 3% stuff all kind of came in. Like you're allowed some variance, but typically you want to try to get it as close to that 120 as possible. So that's just one thing to say, is that there is resistance within the wire itself as well. You can lower the resistance by running a larger wire size, but in the real world, we really don't look at that too much. That's more about kind of like the engineer, or if we're in a situation where you're running like the main feed to the home, that's where you'd be looking at voltage drop, okay? Not so much like in the home, unless it's like a very, very long run within the home. Let's say you have a custom home. Instead of running a number 14, you might say, hey, just run a number 12 to that, even though it needs only 15 amps. We're just going to do it for upsizing the wire, okay? All right, so that is a series circuit. Current is the same. You can add up your resistive values, your voltages, all that stuff in parallel. It doesn't work that way. Let's just bring that one back. In parallel, again, your voltage stays the same, and your total resistive value has to be less than any electrical load in the circuit. All right, so if you guys got questions, leave it in the comments below. I hope this one helps you out. So if you want to stay updated with the website, you can just subscribe on YouTube, but the best way is to sign up to the email list by going to becominganelectrician.com/subscribe. You get my free book. You will stay updated with what I call the Sparky news, which is just articles and videos on the actual website itself. So you'll stay up to date always. All right, so thank you so much for watching. Again, if you ever want to request a video, just feel free to send me an email, and I'll talk to you in the next video.